Problem number 5, we're just trying to maximize the volume of a box with the given parameters. We've got a 12-inch square piece of cardboard, so the 12-inch part goes right here. So it's 12-inch square, so each side of the square has a length of 12 inches, so 1 square foot. And the volume then, after we cut a square out of each corner, we see that when we fold up the corners we have a volume of length times width times height, so x times 12 minus 2x squared. And that particular volume equation, if I multiply it out like this, 12 minus 2x, so I like to multiply the two binomials together first. We get 144 minus 24, and minus 24 is a minus 48x, and then we have a plus 4x squared. And so our volume in terms of x is 4. I'm going to rearrange the order of the terms. Okay, x times each of the terms on the inside of the parentheses. X times the 4x squared would be 4x cubed. X times the negative 48 would be minus 48x squared, and then plus a 144x. So I reordered the terms so I had the largest power first. And if we take the derivative, don't divide by 4 yet, because that's going to mess things up. Okay, so v prime is equal to 12x squared minus 96x plus 144. And what could we divide everything by? 12 times 8 is 96. So we can divide everything by 12 once we set it equal to 0. So v prime is equal to 0 when, when 12x squared minus 96x plus 144 is equal to 0. And again, we can divide every term by 12. So we can reduce our amount of work that we have here. And where could we do that work? We're running out of room here. So let me try a different color so it doesn't totally mess things up. When we divide the first term by 12, we just get x squared. Second term by 12, we get minus 8x. And then we have plus 12 is equal to 0. So if we factor that, we get x minus 6 times x minus 2 is equal to 0. And we get x equals 6. Well, x equals 6, that's going to be too big, because if we take 6 from each side, all we have is 12 to work with, so that's going to be too big. So we get that x is equal to 2. And we know that on the open top box problems, that critical point that we get, we know that that's going to yield our maximum volume, because the volume with x equaling 0 is 0, and the volume with x equaling 6 would be also 0. So those are the low points, and the volume when x is equal to 2 is going to be our high point. So what are we being asked? What is the largest possible volume? Well, the largest possible volume would be, so I'm not going to set up the first derivative test. Okay, if you want to confirm that x equals 2 value is going to give us our maximum volume, then go ahead. Okay, but I'm not going to do that. So our volume when x is equal to 2 is equal to, where's our best bet here? Oh, let's put it in the very first equation there. 2 times 12 minus 2 times 2 is 4, and we're going to square that. So we get 2 times 8 squared, and 8 squared is 64, so we get 128. 2 times 64 is 128, and the volume, we did get units of measure in this one, so we get 128 cubic inches, and that is our maximum volume. And I don't know if you can see that down there. Maybe I'll put that way up here as well. So our maximum volume is, again, 128 cubic inches. Okay. And there's the work.